Okay, so hello everyone, very good evening. So again, I welcome you all back to the session where we are covering class 6 science syllabus for exams that are approaching to us. Also, we are clearing few basic concepts that may be helpful for us in our further classes. Like now you students would move to class 7 in some time. So brushing up the concepts of class 6 is very important. And if your exams are not yet held, we are taking up a revision series where we will be revising the topics and carry out few quizzes. Okay, so I'll just share my screen and we will start revising with the chapters that are in the queue today. Just a moment. Okay, I hope the screen is visible to all and am audible too. Okay, so you can reply to me in the chat box. I have chat box open in my mobile in front of me, so I can easily read your chats, even if I am not changing my screen. All right. Yeah, great. I'm audible to you all and also visible, and the screen is visible too. Okay, so children, we have so far worked on 4 units. Unit 1, 2, 3, 4. Today we have unit 5 and unit 6 in the queue. Unit 5 is separation of substances and unit 6 is changes around us. Also, a small change here. This is not session 3, it is session 4. Okay. Since this PPT was prepared so that it was planned to be taken as session 3, but a few changes have been made, so this will be considered as session 4. All right. So as I said, we'll be taking unit 5 today and unit 6. Okay. So separation of substances. What is separation? What is separation? Separation means separating two things. For example, if from market I bring apples, fruits. If I bring fruits, all right. If I bring fruits, now I told you that I have brought with me bananas and apples, right? And I tell you to separate them. So you keep bananas on one side and apples on one side. Assume here you have kept bananas and here you have kept apples. All right. So this process of segregating things into 2 different or 3 different or 4 different, there can be so many entities in a mixture. So that is known as separation. So I have just used the term mixture. So mixture is nothing but the group where we have different substances. Like as I said, fruits. Fruits is a collective noun and it is termed as a mixture. Mixture is a substance which has one or more not one, 2 or more substances in it, right? It can be like, as I said, fruits. It can have bananas, it can have apples, it can have grapes, it can have oranges, watermelon, n number of fruits. So that is why we call mixture a group of substances. And from this group of substances, we are separating out substances, and that is separation. So I hope the basic concept of separation is clear to all. Okay, so you can always react to the chat box. Also, if I ask you, you can turn on the mic. So currently I'm saying that you can reply through the chat box. Okay, here is someone who has sent bananas in the chat box. Okay, great. Okay, now, okay. I have seen so many fruits now in the chat. Great. Okay, so let's move ahead. Okay. Yeah. So, okay. So here are 3 images in front of us. First one is this churning of milk. Churning of milk. Why do we churn milk? to separate out butter, right? Milk has cream in it, which when churned gives me butter. Butter is a milk product, right? And it is in a mixture called milk. And I carry out some process which is known as churning to separate out butter from the mixture milk, right? So what did I do? I took a mixture milk. This is a mixture. And from this mixture, I separated out a substance known as butter, right? So why did I do this separation? Because I needed butter. I wanted to get some butter so that I could eat it, right? I could apply it on my bread. So that's why I churned out milk. So why was separation carried out here? To get a good product, the required product from the mixture, right? Please listen carefully to the terms I am using. Why did we carry out separation? We carried out separation. I'll write it here, just a moment. So I have just asked you all a question. Why did we carry out separation? And also I have answered it. Okay, separation. Why? Why did I carry out separation? The reason was to separate out what to separate out? To separate out desired component. Component or substance from the mixture. So what was my desired component here? It was butter. Okay, and what was the mixture? Mixture was milk. Clear? I hope this is clear to all. All right. Now next one. What is this happening here in this image? This person is picking out stones from wheat. Picking out of stones. So why is he picking out stones? He is picking out stones because stones cannot be grinded along wheat to produce wheat flour, right? Because that's not good. We don't want stones in our food. So that's why they are being hand-picked. This process is known as hand-picking. We'll discuss this in detail in the forthcoming slides, but still for a general introduction, hand-picking. Okay, so again, the reason is why we are doing this hand-picking, why we are carrying out separation of stones from the wheat. The reason remains same, to separate out the desired components. Okay, but here we are separating out the undesired component. But the thing is same. If I separate out stones or if I separate out wheats, that's all the hand-picking thing, right? To get the desired component. All right. Okay. From the mixture. Clear? Now, similarly, in this third image, you can see it that we are separating tea from tea leaves. This is tea. These are tea leaves. And what is this device known as? This is a stainer. Very good. I can see here in the chat box, many of you have answered it as stainer. Right. So this is a stainer. What this stainer is doing, this stainer is filtering out my tea from tea leaves. Like, just a moment, I'll erase this part so that we can write more on this slide. You know, we have limited space here. Okay. So what is this stainer doing? It is filtering. Filtering. Filtering is, again, as I can say, it's a verb. The term will be filtration. What will be the term? Filtration. We'll study filtration in detail. So you might have heard, you know, we use water filters, purifiers, ROs. What do? They filter out impurities from water so that we can have pure water. So that process is known as filtration. Similar thing is happening here. We don't want tea leaves in our cup of tea. That's why we are using a stainer to filter out tea leaves from the tea, right? I hope that's clear to all. You can always react through the chat box, as I always say. Okay. So children, we just I was just asking you a question. Why do we separate out substances? Why do we need to do this separation? And I also answered you the reason to separate out two different but useful. Okay. I'll just take these examples then. Okay, yeah. So we did. We did these three examples in the above three images. First one was churning of milk to obtain butter. So why did we do that? To remove non-useful components. We remove the non-useful component, that liquid part that we get from the milk after removal of butter. Also, we got a useful component, butter. Right? We got butter and we removed or we threw away. Okay, so like when I separated butter from milk, I took butter and threw away the remaining portion, that liquid part, the liquid component. So it has been mentioned here in this table. What do we do with the separated components? So in case of churning of milk, we throw that, right? Similarly, we did the next example where I told that we are picking the stones from wheat. Okay, it can be wheat or rice, anything. It was not clear in the image. So we can assume it to be rice or wheat, anything. So what did we do? We separated two different things. We separated out stones, we separated out wheat or rice. What did we do with the stones? We throw away the solid component. Solid means here stony component or stones. Okay, we throw away the stones. Similarly, we did the separation of tea leaves from tea through a stainer. We remove the impurities or harmful components, the tea leaves from the tea. We use both the components. Okay, so we can use both the components, right? Tea, we will drink tea. We will drink it. What we will do with tea leaves? Anyone in the chat? What we will do with tea leaves that we are separating out? Yeah, it can be used as a manure. What is manure? It provides nutrition to plants. We can add it to soil. It can be converted to manure. Okay, great. Well, that's not the scope right now. It's not needed. Just for your knowledge, I have answered it here. But the main thing is that we are filtering out the tea leaves from tea to get pure tea via a stainer. That process is filtration. Now, since we are talking about separation of substances, there are few processes that we need to study. There are 5 processes mentioned here, but I will teach you 6 processes. Sixth process that I will be teaching you would be evaporation. Okay. So sixth one is not right. Okay. So first one is hand picking. Hand picking we have seen in an image where we were picking stones from rice by hand. That was hand picking. Then next one we will see threshing. After threshing, we will move to winnowing, then sieving, and then sedimentation, decantation, and filtration. This can be termed into a single process. And the sixth one will be evaporation, which we shall discuss now. Okay, can you see this image? This is nothing but sieving. Okay, I'll show you in the further images. Okay, then that will be clear. Hand picking. Yeah, perfect. Hand picking. What is hand picking? Picking up of impurities by hand. Picking of impurities by hand. Right? Like this person is picking up stones from this, I guess it is dal kind of something, grams. Right, so this guy is picking up these stones present here. One more is here, right? So he is picking these up. This is hand picking. Method of hand picking can be used for separating slightly larger sized impurities, right? If these stones are very small, which are even not visible to us, we cannot pick it out, right? So the impurity size should be larger enough. Like the piece of dirt, stones, husk from wheat, rice, or pulses can be separated by the method of hand picking. Right? I hope it is clear to all, and it's very easy. So they can ask you many questions like which of the following can be separated out by hand picking. So you can like use your intellect and answer the question that you can just try out things like you can take it like we are separating out stones from wheat or rice that we have just taken. Okay, so very good. You can give more examples in the chat. I am reading it out here. Right. Great. You are right. Yes. Okay. So next is threshing. After hand picking, we have come to a process called threshing. Now, what is threshing? Threshing is a process of separation of stalk from grain, or I should say grain from stalk actually, sorry for that. The process of separation of grain from stalk. Grain from stalk, S-T-A-L-K. Now this is stalk of the wheat stalk. What will the farmer do? He'll take a group of stalks in his hand and he will just, what he will do? He will beat that on a platform like this. This be the platform. And after beating, he'll beat it with a very high pressure that, wheat grains separate out. What he will do? He'll beat the stalk so tightly, so much pressure, with so much of pressure that the wheat grains will come out, will liberate out of the stalk. And this is the process of separation of wheat or any grain from stalk, right? So I hope this is clear. He'll just take it in his hand, throw it with a huge pressure on the platform and separate out the grain from stalk. Clear? It's very simple and easy. So it's written here also. The process is used to separate grain from stalks, etc. in threshing. In this process, the stalks are beaten to free the grain seed, right? As I just said. The machines are also used to thresh large quantities of grain, right? If there is a huge field, this cannot be done by human being alone. So we go for automation of processes. And children, Industry 4.0 and 3.0 that has just come up, it deals with automation majorly. And I hope you know Industry 4.0 and Industry 3.0. You can just read out these articles on internet. What do they say? That the current industry needs an automation of processes, right? Now, human labor has been reduced considerably. We go for various processes via machines, and especially the agriculture industry, agrobots have come up into a huge, trend to these days. Like people are going for the robotics help, right? So you can always, read various articles that will help you to generate an interest towards science and technology. Okay, so next process that we are coming here with is winnowing. What is winnowing? Winnowing is a very simple process. Like as you can see, this lady standing here, she has a mixture here with her in her hand, mixture. Now from this direction, wind is blowing. So what will happen? This mixture contains one light material and one heavy material. Light and heavy, what is heavy and what is light? If I say feather is light, whereas this mouse, as you can see, this mouse is heavier than a feather, right? Which has more weight. So what will happen? This wind will blow away the lighter husk from the grains. The grains are heavy, they will fall down, husk will move ahead. So this way I can separate my grain from husk. Though this is not very efficient, but it is very, very efficient if we are dealing with, a big sample space. What I mean is that there is so much husk in my wheat. Okay, so I'll go for this process, which is known as winnowing. Always, like we are preparing for our exam, you should always go for spellings. And I always say, children, if it's a question of 3 marks or any n marks, if your spelling is wrong, you will get a 0. Okay, so make sure your spellings are correct. It's scientific subject, it's science. Okay, it is not like other subjects. You need to work on your spellings and the correct keywords. Okay, so as I said, the husk particles are carried away by the wind. The seeds of grains get separated and form a heap. They will form a heap here and they will form a heap. Okay, grains will form a heap here near the platform. The lady standing on the platform. The separated husk is used for many purposes such as fodder for cattle. Fodder means food for cattle. Okay, so this husk we can give to animals for eating. They will consume this husk. Okay, so now we are using both the separated out substances. We are taking use from it. Okay. So next slide, sieving. So in the earlier slides, I showed you, a pictorial representation of sieving. Something like this it was. right? So what is happening? You might have seen your mom sieving out flour at your homes. Why do they do so? Because the flour we bring from market also contains impurities. Here we need pure substance. Pure means that has no impurities. So we go for sieving. It has a net like mesh. It has a mesh in it which separates out larger size impurities, and we get pure flour here, right? So sieving allows the fine flour particles to pass through the holes of the sieve while the bigger impurities remain on the sieve. Also, you might have observed at the construction sites when we bring sand and cements for building purposes. So we use a large size sieves. These are sieves, right? So we just pass this through this sieve, and by this we can remove the stones present in this sand. And there are many other things in sand impurities that are not fit for construction. So we need to remove them. And how we will remove that? Via sieving. Right now, next process: sedimentation, decantation, and filtration. This is very, very important. This will form the basis of your class 7 and 8, not just class 7 and 8. If you are studying science, for till 10th, you will definitely study. And even if you take it in the higher classes, it will be always there with you. So what is this process? Sedimentation, decantation, and filtration. So this is again a process of separation. Here we are separating insoluble solid impurities, insoluble solid impurities from liquid. This can be liquid. This is a liquid. This can be water. This can be, oil. This can be anything. Okay. So what happens? I take a beaker. First, this is a 3-step process. First step is sedimentation. What happens in sedimentation? We take the solution, we keep it for resting. It is in the resting mode. The heavier sand particles or the solid components settle down in the solution. Solution or the mixture. This is a mixture, right? It's the mixture of water and sand. Okay, so the sand particles will settle down and water will be there above. So what I'll do in the next process, the next step, that is decantation, I'll just hold it in my hand and remove the water slowly, that all water comes out and the sand remains here. But still that's not possible. Some sand may come at the end stage near here, right? When I'm close to the sand surface, so there are high chances that sand also comes out. So to prevent that, I go for the next step, that is known as filtration. Okay, this process is not very efficient. This is not efficient. So we go for another step that is known as filtration. What we do, the water that we have got here or here, we'll pass it through a filter paper. Filter paper is a paper that will again allow only the water to pass through it, but not the impurities like sand. Okay, so what we do, filter paper is a circular paper. If we get a very good, good quality paper from market, it comes as cutouts in circle shapes. Otherwise, there are big papers also. You can cut it in the lab. So what we do, we fold it to a conical shape and place it in this conical funnel. This is a cone. This is a conical funnel. It's cone shaped, right? So what I'll do is I'll pass my impure water through this. The sand particles will remain here and the pure water, which is known as the filtrate, and the sand remained here is known as the residue. You will study all these terms in your class 7. Okay, don't worry. Okay, so this is known as filtrate or the pure water. Pure water. Clear? That was very easy. Okay, so you can just read it out through your textbooks. When the solution is passed through a filter paper, this process is called filtration. Also, I have used this term filtration earlier when I was talking about separating out tea leaves from tea, right? There we, what was our filter paper? There, our filter paper was the stainer, right? Very good. I hope it's clear. Next, let's move ahead. This was the process I was saying I'll teach as an extra process. It's not extra. It is there in NCERT textbook, but not has been mentioned as a separate process. What is evaporation? Evaporation is nothing but if I go and boil some water. I'm boiling it. I'm heating it. Okay, I'm heating it. So water present here will change into gaseous form. You all might know that there are three states of a substance: solid, liquid, and gas, right? These are interconvertible. Also, we can go from solid to gas directly. If I take example of water, okay, so water can be freezed to form ice. Oh, spelling mistake. See, very bad is this. Okay, no issues. Water can be freezed to form ice. Ice can be melted to form water. Similarly, water can be evaporated to water vapor, and water vapor can be condensed and evaporated. Okay, so we are dealing with these two topics today, evaporation and condensation. So what is evaporation? Conversion of a liquid state to gaseous state, whereas condensation is the process of conversion of gaseous state to liquid state. So what will happen? I'll take my water in a, this is a kettle where water is being heated up. It will get converted to vapors, which will come out through this nozzle, and I am cooling these vapors. Okay, what will happen? These vapors will come here and strike over this surface. This surface has been made of low temperature. It has been taken to a low temperature. How? I have placed an ice pack here. Okay, so this will cool down. These vapors will cool down and get converted to liquid, which is water. So I'll collect it here. Now, for example, now listen carefully. For example, this was a salt solution. What it was? Salt solution. Water will evaporate, but salt will not. So only water vapors will come out. They will condense here, and I will get pure water here. What will I get? I'll get pure water. It will not have, does not contain salt in it. It does not contain salt in it. So this is also a process of separation of a dissolved solid impurity, or a dissolved impurity can be separated out. It can be sugar, it can be salt, it can be glucose, anything. Dissolved impurities can be separated out. All right. I hope that's clear. It was very simple, it's not easy. It's not tough. Okay, clear? So I have given you plenty of examples. Now we will move ahead. Okay, so I have received all of your responses through this form. So also I have got your scores, and I'm very satisfied with the performance. Almost everyone has got a score more than 90%. So it's great. Like, you all are listening to me very carefully and answering the questions also in a good way. So that's highly appreciated. Okay, so now we shall move with the next unit. I hope this was clear to you all. If you have any questions, you can ask them in the chat box. I am always constantly looking at it. And if you have any problems, you can ask them and I'll answer it. Okay, no queries. So let's move ahead. So children, we have so far seen unit 5. Now let's move to unit 6. Okay, so another additional information that, unit 6 is very small as per NCERT textbook. But, you will study similar unit in class 7 and 8. So I will teach the maximum topics that I can, even if they are not in NCERT. Because, it's okay, it's a revision session, but okay, revision is easy for smaller units, right? So we'll take some extra things today and I'll teach some extra things. So do make sure you are making notes of it. Okay, so changes around us. Changes. What's a change? Anything that changes. Like we have just now discussed. I hope my camera, okay, it's on, right? And my mic is on too. Slides are changing. Great. So what's the change? We have just now discussed an example like if I talk about water, it can be changed to vapor. It can be evaporated. Evaporation is the change or the process. And after vaporization, when it turns to vapor, we can condense it back to water. This process is known as condensation. Right? Now, water can be converted to solid by method of freezing, and this is ice, and ice can be melted back to water. Right? Clear? So what we are doing, we are changing the state of water. We are changing the state of water. This is a change. It can be wax, similar to water. Wax can be melted. Wax is a solid substance, right? Candles, you might have seen candle wax. Wax can be melted to a liquid form, and when the candles are lit, after they are melted, what happens? They vaporize. A candle vaporizes after some time. So that is, conversion of liquid to gaseous state. Clear? So that's a change basically. Now, changes can be anything, change in the phase of moon. Like you might have observed a new moon, or let's go from full moon. Full moon is fully visible. Then, there are many stages of conversion of this full moon to a new moon. It gets a half moon. Then it comes to something kind of this shape. Then it becomes a new moon, which has no visibility, zero visibility, right? So this is also a change. New moon. Clear? So I hope I'm able to make clear the basic concept of change. So like we know now what's a change. Change is something, any change. Okay. So just a moment. Yeah. So changes around us. What are the changes that we may observe around us? We might observe like, blooming of a flower. A flower is a bud, then it blooms. This is a process. This is a change, change in state of flower, current state of flower. Just a moment. This pen is, I'm unable to access the pen. Okay, so change like blooming of flower. Blooming of flower. See how beautiful this flower becomes, but it was just a small bud. It was a bud like this, which has now bloomed to a good and beautiful flower. Similarly, like we can just read out here, many changes are taking place around us on their own. On their own, even no one is changing it. No one is carrying out like change. If I pick this mouse and I keep it here, so this is a change that I have made. This is not a natural change, right? But there are many natural changes that are occurring in nature now. Right, in the fields, the crops change from time to time. Very obviously, first I take a seed, I sow it in the soil, and it grows into a beautiful plant. Right. Sometimes leaves fall from trees. Leaves fall from trees, and then new leaves, they just grow out. That's again a change. Change color and dry out. Yeah, leaf. What's the life cycle of leaf? It grows as a bud, then a full leaf, then it dries out, color changes from green to brown, and it falls off. So that's a change. The flower blooms and then wither away. After it blooms, one day will come that it will just wither away. Okay. Also, your nails grow, your hairs grow, you grow taller, your weight increases as you grow. So there are many changes taking in us and around us. In us and around us. Clear? So that's pretty much about the changes in and around us. Now, there is a category of reversible and irreversible changes. Okay, so I'll explain it in detail on a Jamboard file. Just a moment, I'll change the screen and we shall discuss it in more detail. Just a moment. Yeah, I hope this is visible to all. Actually, the reason for changing the page is that, it was not clearly visible there. Yeah. No, this is not nice truth. Yeah. Ha. So as I just said, there are a group of changes that are irreversible changes, and there is a group of changes that is reversible. That is reversible. So what happens in irreversible changes and reversible changes? Changes that can be taken back to the initial state are known as reversible changes. What does this mean? For example, if I started from water, water, and I just freezed it, what did I do? I freezed it and it became ice. Now from this ice, I can just melt ice and I can go back to water. So the states can be brought back after carrying out suitable changes. Now, if again I freeze it, I'll get ice. If again I melt it, I'll get water. So the states are convertible. States are convertible and changeable. Clear? They can be reversed back. So this is a reversible change. Whereas an irreversible change is a change that cannot be reversed. That cannot be reversed. Right? Cannot be reversed. What does this mean? That cannot bring back the initial state. For example, if I take an iron nail, okay, and if it rusts out, rusting, rusting. I'll just change the screen. Rusting. What is rusting? You might have observed that on iron objects, uh, that reddish brown coating appears. Reddish brown coating. This is the rusting. That kills iron. That kills iron. This is rusting. This is that reddish brown coating is known as rust, and the process is known as rusting. Process is known as rusting. So this is an irreversible change. If this rusting happens on my iron nail, if this was my iron nail, and if this rusting happens, I'll just draw rust with another color for a better clarity. Let's say yellow color. Okay. So suppose this rust grows on my iron. I cannot remove it. Okay, this can be removed, but the initial state of the iron nail cannot be brought back. This is not possible. This is not possible. Hence, this process is irreversible change. It is irreversible change. There is another group of changes which are known as desirable and indesirable or undesirable changes. What is the meaning of desirable? What I want, right? If I want that, the next day onwards I become topper of my class. So how will I become the topper of my class? I'll become topper if I start studying. So if I study, there will be change in the position of my position in class from third or okay, whatever be the position. Assume I am the last student, and if I study constantly, I will be the first student, right? So this is a desirable change. This was a desired change, right? Similarly, if I stop studying, and assume I was on the first position and now I will move to the last position. So this process will bring a change that is not desirable. That is not desirable. Can you give me more examples of desirable and undesirable? I am reading the chat box. Okay, great. So I will also give you some examples, like for example, desirable change. If I talk about, okay, first let's talk about undesirable. Souring of milk. Milk, milk gets soured sometimes when we, do not take care of the milk. Like if we keep it just in open and do not keep it in the refrigerator, it sours out. So that's an undesirable change, souring of milk. A desirable change, like growth of human being. Right, we want that change to happen, and that's a desirable change. If you study your change in position in class, as we have just discussed, change in position in class. So there can be many desirable and undesirable changes. Clear? So that was pretty much I wanted to discuss about changes. Okay, so now I'll move back to the PPT that I was sharing. Just a minute. And if needed, we'll come back again to the Jamboard. Just a moment. Yeah, so we have just now discussed about irreversible and reversible changes, right? So what are the reversible changes that can be brought back to the initial state, reversed back to the initial state where we started from? Okay, and irreversible, we cannot come back to the initial state, cannot be, cannot. And yes, we can come back to initial when we are taking out a reversible change. For example, if I blow a balloon, blowing of a balloon. So, like if I blow a balloon, it will grow in size. But when I deflate it, it will come back to its original state, which is in which. Okay, so I think I should continue because if the child joins in between, I'll take a quick recap again. Okay. So, like I was just saying, blowing of a balloon. So, what happens while we are blowing a balloon? Initial state can be achieved if we deflate it. So, empty balloon to a filled balloon, then back to empty balloon. It's a reversible process. Whereas, if I just knead a dough, kneading of a dough, we take flour, we add water to it, and we get a dough. So this dough cannot be taken back to the stage of flour, right? This cannot be taken back to the stage of flour. Hence, it is irreversible process. It's irreversible process, right? These two examples have been taken from NCERT textbook. So these are, from your text. So you can definitely go through them even when you are reading the text. Okay, so next. Change is due to heating effect. Okay, let's move to Jamboard. I'll explain more there on Jamboard. Just a moment. Okay, heating effect. What happens on heating? Firstly, there can be change of state. Also, there can be change of shape. So change of state we have already studied, state how changes from, liquid to gas, also from gas to liquid, then liquid to solid, and solid to liquid. Also, there are sometimes changes directly from solid to gas and gas to solid. Okay, that we are not studying today. So we have studied about the change of state. Now, if I'm talking about the change of shape, okay, just a moment, there was an unexpected stroke. Yeah. So change of shape, like what happens if I take a plastic bottle. Plastic bottle. So what will happen if I heat it? The shape may change like this. It just gets something like this, right? So this is change of shape. Similarly, like it's a general phenomena observed everywhere. You will study in detail the scientific reasons in the forthcoming classes. When the substances are heated, it expands. Whereas when cooled, they compress. What happens? They compress. When the substances are heated, they expand. When cooled, they compress. More I'll explain. There is you might have observed carts, C-A-R-T-S, bullock carts, and there are carts pulled by horses, pulled by bulls. So these carts have wheels, we call them cart wheels. These cart wheels are made up of wood, something like this. These wooden cartwheels cannot be used unless they are covered with a metallic rim. Unless they are covered with a metallic rim, they cannot be used. Why? Because wood will just tear off after some time. We need a metallic rim. And what we do, we take a metallic rim of smaller size. We heat it. It expands. It will expand in size. The size will increase. I will take my wooden wheel and keep inside it. And then I will cool it down. When I cool it down, this will shrink and my metal rim will tightly fix the wooden wheel. Are you getting my point? What will happen if I take this wooden wheel? Okay, and this is my rim. This is correct size, but I cannot fix it easily. So what I will do, I will heat it, it will expand. I will put the wooden wheel inside it and I will cool it so it will shrink. So it will form a tight connection. It will be tightly held. So this is the process. It's basically the general application of heating effect. Changes due to heating effect. So what are the changes that we observe due to heating? First was the change in state and then was the change in shape. Right? Okay. So I'll again come back to the slides that I was sharing. A window. Right, I just explained you heating causes expansion. On heating, the rim expands and fit onto the cold wheel. See, right? I just said when we heat it, it grows in size, it expands, and we just cover it on the rim, and then we just cool it. It will contract and fits tightly onto the wheel. This is a general application. Okay, this is an application of heating effect. Then. Next. Oh, we have reached to the end. Okay, so also before we move ahead, I'll explain a few more concepts. Like we have just discussed about rusting, right? So once again, we'll take a quick recap of rusting, then we'll move to the quiz. Like I just said that it's an iron nail. On iron nail, there is formation of a yellowish brown coating. Okay, let's draw it with a brown color so that it is visible. This coating cannot be removed, and if removed, it will come out with the iron in it. Actually, what happens, there is a chemical change. Okay, again a change. So I'll again come back to the Jamboard and explain one more concept I have just come up with. Because, you know, we should discuss something extra when you are here at SUVY, not just the school stereotypes, right? Okay, so I just said a chemical change and a physical change. Okay, so children, if in case you do not understand it, don't worry. You will study it in your class 7 and 8. But still, since you are here with us, it's our duty to explain something extra that's not taught to you in school, right? So chemical changes are the changes that change the chemical composition of the substance. Whereas physical changes are the changes that carry out a physical change, physical composition changes, like change in shape. For example, if I blow a balloon, right, this is change in shape. And when I'll deflate it, it will still remain a balloon. Balloon will not become a ball, right? It will not become a plastic ball. Whereas if I go for rusting of iron, iron will turn to rust. Okay, so for example, if this is my nail and this part, this covering turns into rust. This has turned into rust. Now it's no more iron. Okay, so when I will remove it, my nail shape will become like this. The iron that was present here has been now removed. This iron that was present here now has been removed. So this is a chemical change. Okay, so I was just explaining it here in the slides as well, that this is a change that cannot be reversed. It's an irreversible change. It's an irreversible change, right? I hope it is clear. So now we shall be continuing with the quiz. I'll share the quiz link in the chat. And again, like it's 5:59, and what it's like, it's almost the end. So I shall share two links now. Okay, two links. One is the quiz link plus a feedback link where you can share your feedbacks. Did you enjoy the class or not? So okay, and you can give me a rating like 1 to 5. There are 5 options and you can just answer them out. So I shall share the links now in the chat. Now what's your duty? You will have to answer it, both the forms, and after answering you are free to leave the class. Okay. Also children, as I always say that these feedback links and these quiz forms are the mode of attendance, so make sure you fill them correctly because we have to maintain the records and data of the students we are teaching and your performance in the class. Okay, so I should share the quiz link now and the feedback link, so do mark them. Okay.